Hello everyone. Now we'll be seeing AM demodulators. So at the transmitter end, we had observed once the signals are being modulated, those signals are being transmitted through a transmitter. Now the transmitted signals are being received by a receiver to retrieve back the information signal or a message signal. To retrieve that message signal or the original signal, there are two types of modulators. First one is square law demodulator and next one is envelope detector. We'll see one by one. The first one, square law demodulator. This square law demodulator, it mainly consists of a square law device, a low pass filter. Now the input to this square law device is an AM wave, that is a modulated wave which is represented as V1 of t. That V1 of t is fed to a square law device. The output of this square law device is V2 of t. That V2 of t is fed to low pass filter to retrieve our original modulating signal. Now the AM wave V1 of t, that is acting as an input to an square law device, is represented as V1 of t is equals to AC into 1 plus Ka m of t into cos of 2 pi fct. Now the input output of a square law device is represented as V2 of t, and V2 of t is expressed as K1 V1 of t plus K2 V1 square of t. This is similar to that of what we had seen at the modulator end also. Now represent that one as equation 2. Substituting equation 1 in this equation 2, V2 of t is written as K1 into V1 of t. What is V1 of t? V1 of t is nothing but AC into 1 plus Ka m of t cos of 2 pi fct plus K2 into the entire thing. Now it is square. Now solving this, we'll be getting K1 AC into cos of 2 pi fct plus K1 AC Ka m of t cos of 2 pi fct plus K2 AC square. Now this is square. K2 AC square 1 plus Ka square m square of t plus 2 Km of t into 1 plus cos of 4 pi fct divided by 2. Solving this, we'll be getting K1 AC cos of 2 pi fct plus K1 AC Ka m of t cos of 2 pi fct plus K2 AC square divided by 2 plus K2 AC square divided by 2 cos of 4 pi fct plus K2 AC square Ka square m square of t by 2 plus K2 AC square Ka square m square of t divided by 2 cos of 2 pi fct plus K2 AC square Ka m of t plus K2 AC square Ka m of t cos of 4 pi fct. Now this is the output, but this entire thing is not required. This V2 of t, whatever it's been obtained, that is being fed to a low pass filter to get back only this m of t signal, which is our original modulating signal. So as this is a low frequency signal, the output of this low pass filter is nothing but K2 AC square Ka m of t, and all these signals are being filtered out, and this K2 AC square is nothing but the scaled version of m of t. We'll see another method of AM demodulation, that is nothing but envelope detector. Here also same thing, the AM wave is fed as an input to a diode, and the output of a diode is fed to a low pass filter to get back our demodulated wave or a message signal. So this is nothing but a block diagram of an envelope detector. We'll see now the circuit diagram, wherein in this circuit diagram it consists of a resistor RS, a diode, a capacitor and a load resistor RL. We know that the standard AM wave is represented as S of t is equals to AC into 1 plus Ka m of t into cos of 2 pi fct. Now this S of t is being fed to a diode. So in the positive half cycle of an AM wave, this diode, it conducts, and the capacitor will start charging to the peak value of an AM value. Once that voltage is less than Fm, then the diode will stop conducting, that is it will be in reverse bias condition. When it is in the reverse bias condition, the capacitor will start discharging across the load resistor RL. Now we can see two figures here. The first figure is wherein you can see that there is lot of ripples which are being obtained at this output end. So these ripples have to be cleared, or it has to be filtered. So once that ripples are being filtered, then we'll be getting back our original signal. So for getting this ripple free signal, the choosing of RC time constant is very important. Thank you.